So here's a quick brief what we did in class for this worksheet, and it really was. I liked it because I really hammered down the all forms and when to do what. And you don't need to see my face, so I'll close that off here. But I asked class, "What form is this?" And then they were able to tell me as a group, "This is standard form, Mr. Samuelis." And if you were missing on the standard form day, you got to watch these videos. You can't just try the homework without looking at the lesson. So standard form, and then that's that magic formula, negative b over 2a. So I kind of put my pen here kind of to, maybe this is good. So, and then it's coming out of left field. If you didn't watch that video, it just is. And I told my students, I'm not going to really tell you where this comes from. It's just true that you got to remember a formula sometimes. And that's the case with this one. So there's b. A is -1, C is -36, ax squared plus bx plus c. So you do negative b over 2 times a, and you end up getting 6. So I'm pointing to that 6 right there. And then I made the student plug that in class to find the y. Input, say it. Output. So they get, and then be careful on this negative x squared. No, that is not squared. That is stays on the outside. So you square 6, then you slap a negative on. Negative 36 and negative 36 is negative 72. 6 times 12 is 72. So this ends up being 0 as an output. Probably should clean this up. This chart is like, I did that wrong here. Kind of squeezed my chart values in here. So that's 6 comma 0. And then we graph that. And then some students are getting to figuring out that the next set of points are down 1 over 1, down 1 over 1, because it goes down. And that is the slope, quote, I mean, I use that term loosely to get the next set of points. And you can check yourself. So that's why we went 5 and 7. When you plug in 5, you're going to have to evaluate. All right, plug it in and evaluate and be good at that. We're in honors math too, so we should be able to use order of operations and get those output values. Yes, you do get -1. Don't plug in 7 because there's symmetry. So 5, if that gives you -1, 1 away from the vertex, 7 should also give you -1. And then even though it goes off the scale, one positive thing about the standard form is finding the y-intercept. You plug in 0 for x, this all turns into 0. And then I'm left with -36. So that's why 0 comma -36 is the y-intercept. Off the screen, fine. So we won't see this in the graph. That's okay. But then that's why 0 to 6 is 6 away, 6 to 12. 12 comma -36 would have. If you plugged in 12, you would get -36. And you can check that on your own. Axis of symmetry is always a vertical line, x equals. X equals the x coordinate of the vertex. Maybe the eraser is better. Then I asked the class, what form is this? 3, 2, 1. They were able to tell me that it was vertex. So only you can get yourself to recognize these forms. I will not be able to help you do that. I've thrown the information out there. Now it's your turn to, get those figured out and know their attributes. For instance, ask the student, what's the vertex? 3, opposite of negative. When I plug in 3 for x, this becomes 0. That is the vertex value, x coordinate, whatever makes this 0 on the inside. So that's why it's opposite. Same. Well, I plug in 3, 3 minus 3, 0. 0 squared plus 3 is 3. Yes, I ignored the negative because there's no such thing as -0. Then same thing, that a value, down 1 over 1, we could cheat. Or you could plug in 2. Order of operations, 2 minus 3 is -1. Squared is 1, but then you throw a negative on there. And now that becomes -1 again. Order of operations, PEMDAS. Plus 3 is 2. 1 away, 1 away. 4 comma 2 as well. 4 is actually easier. 4 minus 3 is 1. 1 squared is 1. Then negative. -1 plus 3. And then I did I just for giggles, you could have done 1 for your next input value, but I did 0 just to prove that that's a y-intercept. And then the person calculated -6. So 3 away, 3 away, and then you should be able to do axis of symmetry and maximum on your own on that. Okay, fine. X equals 3, axis of symmetry. The maximum, again, because this goes down, is 3 located at x equals 3. That's how you answer those questions. Should have done domain and range, but I didn't. And then I asked the student, what form is this? And they said intercept, because when I plug in 4 for x, I get 0 for y. That is an x-intercept. When I plug in 3 for x, 0 times who cares is 0 for y. Input, say it. Output, right? So then they graph those. And then I said, oh no, what is the vertex's x coordinate? And they thought about it for a little bit. They were a little nervous, and I think fractions do that to us. Then my second hour person said, 3.5. And I go, yes, it's exactly in between 3 and 4 for this. It has to be. We should know that this parabola is going up. Sorry, you're going to tickle my throat. Excuse me. Okay, so 3 and 4, 3.5 is the x coordinate. And then you plug it in. 3.5 for x, evaluate. And if you sadly need your calculator, I guess on this one it's okay because of decimals, but I went through a fraction thing with my class and why I don't need a calculator. But blah, blah, blah. You get -0.5 as an output. Input 3.5, the output's -0.5. Write the input down and do the evaluation. Really hope that's not the problem in this high level math class, just simple evaluations. And then I just picked 2. So one more over here. Plugged in 2 minus 4 is -2. 2 minus 3 is -1. -2 times -1 is 2. 2 times 2 is 4, doing order of operations. Boom. Same thing with 5. 1 away from 4, because we do have that symmetry again. All right? So know your forms. Intercept. Standard is this magic formula. Watch that video. No excuses for not doing that. That's why the videos exist. And then vertex form, knowing that, and blah, 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 blah. So we spent a day on balancing the forms and getting them kind of figured out and what their attributes were.